IGC, IG1Element number 3, video number 10. Very good video, hierarchy of control. This video is not only for the NEBOSH and IOSH students. This video is for the IGC professional who are directly involved in the implementation, directly or indirectly involved in the implementation of the management system. When we are talking about the hierarchy of control, is coming the 5 areas or 5 items will be including in this video as per the hierarchy approach. Elimination, substitution, engineering control. If not control, then provide administrative control. Then and the last, provide the PPE. Or simply, if you want to have make this very simple, the wording ERIC PD, ERIC prevent death, ERIC prevent death. Elimination, reduce, then isolate, then control, then PPE, and then discipline. So now we start this one by one. What is hierarchy of control? Hierarchy of control is a system used to eliminate or reduce exposure to hazard. The hierarchy of control fixes the environment, not the person. What's the logic of hierarchy? The hierarchy of control fixes the environment, not the person. The 5 levels of the hierarchy of controls. The hierarchy is an inverted pyramid showing the most effective control at the top, and the least effective but necessary control at the bottom. So now we take this one by one. Ranking. Elimination. The first one is the high. Elimination. Description. Physically remove the hazard. Examples. Let's apply this for the noise hazard in a workplace. Outsource the noisy task. Give this to a contractor or outsource. Then substitution. Replace the hazardous material, process or machine with the least hazardous one. Like replace, if we have a machine like grinding machine, so change this or change this with water jet cutting machine. So the noise will be controlled. Engineering control. Isolate people from the hazard by modifying the work environment or equipment. Building an if we have a generator or if we have a compressor, keep this in enclosed area or install a noise absorbing sheet for it. Administrative control. Now again we are applying this for the noise because we select the noise. Administrative control. Develop a procedure, SOP, then provide training or job rotation. So how? Examples. How? Provide a work rest schedule to limit a worker's time in the noisy area or posting a hearing protection required sign. Now PPE. Now if it's not possible, then protect the worker with personal gear as a last resort, barrier between the worker and the hazard. So requiring the worker to wear earplugs or ear muffs. Why the hierarchy matter? The hierarchy is critical because it forces safety professionals to choose control that are passive and systemic over control that rely on active human behavior. Reliability. In engineering control, like a machine guard, work every time passively. A PPE control, like safety glasses, only work if the worker remembers to put them on. Effectiveness. Elimination. Permanently solve the problem. PPE only manage the consequences of exposure. Protect your eyes. Cost. While engineering control can have a high initial cost, they usually offer better long-term cost efficiency compared to the recurring cost of training, monitoring, replacing PPE, and managing incidents. The engineering control are long-term control, and we do not need uh, to uh, to control this time to time for recurring cost, training, monitoring, replacing PPE, and managing incidents. Now, what are engineering controls? Engineering controls are physically changes made to the work environment, equipment, or process that aim is to eliminate, block, or contain a hazard to prevent it from reaching the worker. Provide passive protection. Once implemented correctly, they work automatically and better than administrative control and PPE. Uh, the key strategies for engineering control. Uh, Engineering control fall into three primary strategies: isolation, automation, and ventilation. So these are the three strategies. Isolation: separate the worker from the hazard. Process: equipment modification: modify the equipment, change the hazard. Local exhaust ventilation (LEV). If there are some fumes or smoke or something, we can use the for better dilution, we can use the local exhaust ventilation. Uh, Now we take this one by one: strategy, descriptions, and examples. Contaminants: building a physical barrier or enclosed around the source of the hazard, placing a noisy compressor inside a sound dependent cabinet to prevent noise exposure. Guarding: install physical guarding on moving parts to prevent contact, using interlock safety gates or machine guards that automatically shut down equipment if a worker attempts to open them. Distance: designing the process to increase the space between the hazard and the worker, using longer hoses, leads, or extension cords for pneumatic tools so the worker is further from the noisy uh, motor or vibration source. Barrier: placing protective structure between the worker and the hazard, installing lid line screen to protect staff from radiation. If we have radiation, so in this case, lid line screens will be there. Now, the second one is process equipment modification, change the hazard. This strategy involves modifying the equipment or tool itself to reduce the hazard intensity or remove the hazardous condition. Now, reduction: change the way a machine operates to lessen the energy release, using a wet cutting method with water instead of dry cutting to eliminate dust hazard and sparse at the source. This method, in the example, this is in the tile company. In the tile company, this is properly they are doing this. So how they control the dust? They are using the wet process. Automation: using robotics or remote control, so worker do not need to be in the hazardous area or hazard area. Programming robotic arm to handle repetitive lifting tasks or operating a high pressure valve from a remote control room. Vibration damping: installing materials that absorb or redirects kinetic energy, fitting power tools with anti-vibrations handles or placing equipment on rubber mounts to prevent vibration. Local exhaust ventilation (LEV). This strategy physically captures and removes airborne contaminants before they can enter the worker breathing zone. Source capture: using a hood, dust, or snorkel to capture contaminants right at the point where they are generated. Installing a fume hood or a capture hood over a chemical mixing station to suck fumes away. Dilution ventilation: adding fresh air to dilute the concentration of contaminants in the entire work area, using large exhaust fans to circulate and refresh the air in a warehouse where solvents are used. Now, advantages of engineering control. What the advantages we have had from the engineering control? High reliability. They are independent of worker behavior. If a guard is installed correctly, it provides protection regardless of worker training or attention level. We do not need this training and attention level. So, permanence, they are generally integrated into the design of the facility or equipment and remain inactive for the life of the asset. Protection for all. They protect everyone who enter the controlled area, including visitor and contractor, not just the trained employees. So everyone will be engineering control provide protection for all, the trained or not trained. Reduce recurring cost. While the initial installation may be high, they reduce long-term costs associated with providing, inspecting, fitting, and replacing PPE as well as managing worker exposure and incidents. What are administrative control? Administrative control are changes to the way people work. The rules, procedures, work schedule, and training that limit exposure to a hazard. Why they rank lower than engineering? What's the reason? Administrative control rank lower than engineering control because their effectiveness depends entirely on human behavior. If a worker forgets a procedure, skips a rest break, or ignores a warning sign, the control fails and exposure occurs. Key strategies for administrative controls. Administrative controls primarily fall into three categories: work practice, exposure limitation, and communication training. Now we have strategy, description, and examples. A written procedure, detailed step by step procedure, work instruction, method statement. Now SOP, the exact sequence for shutting down a hazardous machine. PTW, a formal documented system requiring authorization before a specified high risk work can start, requiring a signed confined space entry permit. Housekeeping, procedure to maintain cleanliness and orderliness in the workplace, implementing a daily schedule for cleaning debris from walkways to prevent slip, trip, and fall hazards. Now, incident reporting. Establish a formal process for reporting near misses, incidents, and hazard immediately, mandating that all near misses events be reported within 24 hours to track trends and prevent future accidents. Second one is the first is the safe work procedure and policies. Second is the exposure limits, job rotation, description, rotate worker through different tasks to limit the time each individual spend perform a hazardous activity. Examples: rotating worker between a noisy production floor and a quiet administrative task every 2 hours to limit daily noise exposure. Work rest schedule. Uh, Prescribing mandatory rest breaks based on environmental conditions or workload, requiring a 5 minutes rest break every hour during hot weather to prevent heat stress and fatigue. Restricted access, limiting who can enter a hazardous area and when they can enter, restricting access to maintenance area to only authorized and trained personnel during specific hours. Now, training and communication, training and certification. Educate employees on specific risk, provide them training, require all new employees to complete chemical safety training and pass a competency test before working in the lab, because this is the mandatory training course or something. Working in sign labels, using signs, posters, and labels to communicate immediate hazards are mandatory actions. Flashing cautions, wet floor, signs are using clearly global harmonized system labels. Health surveillance, monitor the health of workers exposed to specific hazards to detect uh, early adverse effect. Conduct annual hearing test for worker in high noise environment to ensure engineering and administrative control. Limitation of administrative control relies on supervision. They require constant supervision and enforcement to ensure compliance. Behavior dependent, their success brings on every worker choosing to follow the procedure which is subject to human error, fatigue, or complacency. Do not solve the hazard. They never actually uh, remove the risk. They only minimize the chance of contact. Ultimately, administrative control are the necessary framework for managing risk that cannot be entirely eliminated or blocked by engineering control. They are the essential system that support a robust safety culture. For this, the administrative control, engineering control, particularly for the NEBOSH students require because in their column number four, they have to write the hierarchy, the actions, and uh, they have to consider the hierarchy of control, like first elimination, then engineering elimination, substitution if possible, isolation if possible, and after this they have to go for the engineering control. After the engineering control, they have to consider the administrative control. But in the administrative part, there are three parts, so they have to consider one by one, and then in the last they have to consider the PP. If any students they do not follow this hierarchy properly, then they will get failed. Because for the NEBOSH IG2, the passing is 100%. So if there is one problem only in one hazard, because at least minimum 10 hazards you have to write. But if there is up and down only one, then it will get failed. So if you have any comments regarding this video, please give this in your comments. And to understand this more and more simple for you, we have other videos for the IG2 also, and for the practitioner we have the risk management. So watch the risk management video also. Thank you very much, and we'll see you with the next video.